So, Ashley, thank you very much. I really like the work that you're doing. It's lovely to see the knowledge graph and the machine learning coming together. I keep on saying to everyone, there's nothing worse than a business glossary death march when you're doing it all in Word and you spend hours and you know that this thing's not going to last. Uh, Word, Excel, all those things. And my biggest, I love the knowledge graph where we can bring all of this together and not waste all our time in things like Word or even data modeling. And this is what this session's all today. But so, Ashley, really look forward to understanding your context, how you make it real for us. Look forward to it.
Well, thank you. I hope I live up to those expectations. No pressure, no pressure.
No pressure, no pressure.
All right, so let me get my screen share going here. When you can see my screen, please.
Can see it now. Can see it now.
Awesome. All right. So those that might not know who I am, so I am Ashleigh Faith. I do have a day job, but for most of my presentations and everything that I talk about, I am on YouTube, where I have a free educational channel. Where I say free because, like, a lot of people, charge for what they do on YouTube. I don't. I do it to help people get education on a lot of these topics that kind of seem hard to get into. Maybe people feel like you have to have a PhD or a lot of schooling, and not everyone has that available to them or can afford to do so. So that's why I do what I do. I try to make it relatable. So, if you're not deep into the tech, you can still understand what I'm talking about. And I have a really popular series called, something 10 minutes or less. And we talk about a data topic, and I have to talk about it in 10 minutes or less in an easy, approachable way, so that, my guideline is always my grandma can understand it or my 5-year-old niece can understand it. Now, I don't know if I get the 5-year-old niece one all the time. I don't know if I meet that criteria. But I do know that a lot of folks like that because it's a deep dive into something in a relatable way. So today we're going to be talking about, how can you retain and recover context for machine learning applications? And the way that we're going to do this is talking about taxonomies and knowledge graphs. So there's a ton of different ways to use knowledge graphs out there in the world. This one is talking about how you can use a knowledge graph framework to map different taxonomies together without losing context. And so that's what we're going to be talking about today. We're also going to be talking about how you can use a lot of taxonomies that are open on the web. There's the linked Open Data Cloud. If you don't know it, you should definitely go look at it because there is a ton of really good data there. And the problem with that is it's got a lot of different contexts. It's in different various forms of cleanliness or repeatability or trustworthiness, depending on which one you're looking at. I like the linked open data cloud because it gives you a star rating. Again, keep all this with a grain of salt because there's no date on when those stars were given. So just keep everything you look at and make your own decisions on it. But what we're going to do today is walk through, why do you need to worry about any of this? What's the benefit of it? Some tips and tricks, things to watch out for as you're doing this. This is all from my experience of over 15 years of working in the vocabulary and content search knowledge graph space, where you have to map together a lot of vocabularies, a lot of different data sources and schema. And these are the ways that I've done this in my past. So also, if you want to go and follow me, I'm over on YouTube. It's just under my name, Ashleigh Faith. And I post lots of videos on all of these topics. Okay, so we're going to go through why it matters. Then we're going to go into where this fits into an architectural pipeline, right? So like where in the flow it would be most beneficial. We're going to talk about the external data, where to find it, how to use it, determining its quality. Then we're going to talk about the internal data because you can't just use all external. You always have to make it useful for your organization and your use case. And then we're going to touch briefly on how to pitch this project, and then we're going to go into questions. Okay, so why does context matter? So here are some examples. Funny enough, the one in the bottom corner with the line chart, That doesn't even exist anymore because it was a knowledge graph. It was, I think, owned by Microsoft, I believe. And it was a knowledge graph all on academic research and papers. But there weren't actual academic subject matter experts or publishing experts or content experts really working on it. And so you can see where the context got a little weird, right? So here they were going through and they were tagging content on what topics they covered. And so here you can see this one is about HLA systems. So it's more medical based. But then if you look over into the topics, which you can see going down the side, it says it's history. Now, why does it say it's history? Because in the text, in the full text, it talks a lot about medical history. So it kept seeing that word over and over again, history. And this is where, with machine learning, it gets really dumb really fast. And so when you, the way that the best way to describe this, and, I know that the world is changing a lot because of, all the LLMs and all of those things. But at the end of the day, machine learning is about pattern recognition, patterns in language, patterns in images, patterns in behaviors. So it's a giant calculator, right? It's a calculator and it's summing up all of these patterns that it sees. And so if you put garbage in and it doesn't have that context, it doesn't know that history has different subgenres, which could be medical, it could be politics, it could be a lot of different things. It's not going to understand unless you give it training, right? So that's how machine learning works. For those that know how machine learning works, I apologize if this is old hat for you. But any machine learning, including LLMs, right? Like you have to train them. You have to give it examples on what humanity actually understands, because it doesn't understand all of those things. Nowadays, we have like BART and other things that are like pre-trained models, which is great, but you also have to think through what were those models trained on, right? And so that's where this context that we're talking about here really does matter. The hierarchy, the metadata, like definitions, looking at the aliases, like the use for, see also, which is how are things interconnected. If you use just a see also, like a traditional back of the book index sort of thing, doesn't give you a lot of context. It just says, yeah, there's some fuzzy dotted line between these two things. It doesn't really give you the context. That's where knowledge graphs help. It can be precise about why these two things are related to each other. And then you look at the assets that you have, the content you have, and the tags on them. And the knowledge graph will help you add the context to those tags. So all of this comes together so that you have a better representation of the world for your organization. So you can see here where I think it was called Microsoft Academic went wrong, where it said the #1 paper. This is the analytics part where we all have to watch, right? Like actions are being taken on these analytics. The #1 paper in history for that year, #1 paper in history was this one about HLA systems. It was not about history in any way, shape, or form. So that's a misfire, right? The other one we'll see here is religious context versus written language context, or the metadata would have been helpful here. So you can see here that the domain is language and linguistics for this character, and that's not. It is, but it isn't, right? So there is a context that is religious, but there's also a context of the written language. It's not really represented here, so it's missing. That's a problem if you're trying to do analytics or doing like content recommendations or anything like that. And then on the other side, you'll see here the context for weight. Weight has so many different contexts to it. So if you're using just pure machine learning, it's just coming out and saying, oh, I see the word weight a lot. But if the context is switching, as it often does in human language, that stuff can get lost. And that context is what helps you make better recommendations, better tagging, and better understanding of the content when you're using analytics. Okay, now, what is the difference between a taxonomy and a knowledge graph? Again, some of you may be very aware of this difference, but It's something that I have noticed gets confusing when using dictionaries or vocabularies within a knowledge graph context, because they both have hierarchies, they both have definitions, they both have, you know, relations between different things and aliases. So they have a lot of similarities, but this is where it gets a little different. So taxonomies are usually created for information by information professionals, often librarians or someone with a content background. Not always, but often. And they are used for tagging and organizing assets. So you tag something with a taxonomy. So taxonomy has tags, and you tag it to things so you can find it or you can take action on something. This actually, I thought, was more well known and more understood. But the problem that I've seen over and over again is people thinking that you're tagging what this thing is about to represent the full context of what this thing is. But what is missing there are things called search indexes, and those search indexes will often look at the full text. So you don't have to worry as much about that. What you do need to worry about is capturing how your users would think about accessing that content based on the tags that you are tagging to it. So you don't have to worry as much about getting an exact match to words within the text, but more about how your users would be accessing it, right? So that's kind of how taxonomies have morphed a little bit in the search engine space. And this is where you need to be very explicit about what is this thing about, not what you think it's about, which when you look at author tags or a folksonomy where your users, maybe your technical writers, are tagging up your own content, be aware of that, because sometimes they'll tag what they wish it was about or what they want it to be about or what they think would be a tag that would get that content being used a lot more by everyone. That's not really the best way to do tagging. You want to make sure it's really pure about what this thing really is, so that anybody who doesn't have that same mindset as the technical writer who or the individuals who are tagging it that are not information professionals. Usually information professionals know better to make sure that it is going to be as widely accessible by those tags. Knowledge graphs, on the other hand, they are often used for search engine optimization. So they're often used behind the scenes to expand when somebody types in the word cat in a search engine. It will expand it to all the other synonyms and languages and other things that cat could go by. And then you have embedded graphs where you can actually start to add even more context. So not just cat, but if you have cats in on parade is the example I use a lot. It's a children's book. Having an embedded graph would help someone understand that cats don't usually go on parade because cats are mammals. They are furry, they have these characteristics, and they don't go on parade by themselves, right? That's usually something that is more fictional, right? And so you can add some of this world logic in when you have a knowledge graph. And usually when you're doing this, you are looking at the explicit relation between two different things, but also the implicit. So that's where you get into the knowledge management of things is, yes, you know that Rome is the capital city of Italy. But if your users think of Rome because there's a code name for a project that you work on that is called Rome, well, if you had a knowledge graph that is pre-built, there's a lot of them now that you can purchase, right? And just use those. Those are still good foundations, but this is where you need to take your own vocabulary, your own knowledge of your users in your business, and also add those layers into the knowledge graph, because it's not going to understand, if it's off the shelf, if Rome is a code name for a project, or maybe someone you work with is named Rome, or, there's a lot of different use cases where an off the shelf knowledge graph would not be able to understand that. And that's where really understanding your users and doing those ethnographic studies where you walk through, like, how would you search for this? What are you doing here? What are the words that you use? so that even though you have a taxonomy that's the preferred labels of things, you have the synonyms and the aliases that your users would use to search for those. Those are the things that we're going to talk about marrying together in this. So why not just use taxonomies as is? All right. Or the linked open data. So most linked data sources are made for a particular use case. So if you're trying to use a taxonomy or a dictionary or a knowledge graph off the shelf, and here is the linked open data cloud, as you can see here. They're pretty general, or they're made for a specific use case, and sometimes you don't even know what that is. So even if you are using something off the shelf, you want to make sure you go through and critique it for your use case and for your organization. Many of these data sets have errors. There's a lot of outdated thinking, for instance, in WordNet, which is a very prominent, I think it's from Princeton, data set for linguistics. They might have corrected it at this point, but I remember using this about 2 years ago and discovering that the definition that WordNet had for an intellectual was a man in the academic space. And I said, I guess my PhD doesn't mean anything, and I can't be an intellectual. Great, right? So you have to be very careful about these things because they're very large data sets. Sometimes they are outdated, and terminology is changing constantly. So, it might have been somewhat permissible to say illegal alien before, and now it's like, no, that is a very offensive way of talking about things, so you need to update it. Also, not all of these data sets are created by the individuals that are represented in those data sets. I have a whole video on my channel if anyone's interested on how to get more representation in data sets from the individuals who are represented in them. And that's one thing you have to be aware of. I remember there was a lot of academic research where we were deriving a taxonomy from back in the day when I was working on something like this. And all the academics were talking about Inuit was the word that they were using in the research. And these were scholars, right? So they should know the proper terminology. But then what we realized is after having different surveys and different ethnographic studies with individuals that would be represented by that term, they're like, no, we still like to call ourselves Eskimos. Whereas, the scholars thought that would be more of an offensive term, but the folks that would be taking on that label were like, no, this is what we call ourselves at the time that was happening. And so that's why you have to really understand what you're looking at when you're looking at these data sets. So always be aware that there is, cultures and people and different languages and different dialects, right? When you're looking at things, you want to make sure that you're doing no harm and you're not expanding on any additional biases. So you always want to make sure that you're checking into those things. And so, when looking at an MIT study recently, the most popular ML data sources had up to a 3.5% error rate. And one of the most popular sources, and I'm not going to mention it because it does have a lot of people using it, 54% error, right? That's a lot. And so, just make sure that you're doing your own data validation off of this, and you're also doing your own checks and balances on things. I think even now with LLMs in the mix, you have to be even more cautious about these things because you have no idea where that data is coming from. And oftentimes the LLM doesn't either. So the source attribution and provenance is hopefully coming along the way with all of those things. But that's where you have to just be very cautious and aware and make sure that you are looking into these things because if it's a generated data set, you really don't know what assumptions are being made with it. Linked data does still need merging and deduping, right? So you're assuming cleanliness when you use a government resource, for instance. That's not always true. I know at least in the U.S., the Library of Congress, you would think would be very, very high quality. And I'm not saying it's not. It actually is. But through the work of a lot of volunteers. A lot of people don't realize that the Library of Congress mines out a lot of the work they do to librarians across the US, which again is not a bad thing per se, but you know, there's a lot of inconsistencies. There's nobody, I don't want to say nobody. There are people that are monitoring these things. There's a lot of it actually that happens, but it's not always guaranteed. So you just want to be very aware and cautious with that. Then there's, you know, different trust levels depending on, you know, what data source that you're looking at. Always look into the same thing with information literacy. Again, I have a video all about that. Information literacy, is it citable? Is it something that you can trust? Just because something is citable, I mean, those in the publishing space probably know this a little bit better than others. There's been a lot of things coming out recently where, you know, scholars who are even peer reviewed have been found to have fabricated data. So again, all with a grain of salt. But you know, overall, you don't necessarily want to use all or treat all data sources as equal. And then many data sources in the library and scholarly fields are not really calibrated for machine learning. I will say this has been the bane of my existence. Right? Like there's been so many projects that have been like, yes, I found this great data source, you know, from this library or from, you know, this institution. And I get into it and it's written like these subject headings at the bottom. Dog dash dash food dash dash recipes. A machine is going to look at that and throw up. It's going to be like, wait, what is this? What are you doing here? You know, even as something as simple as reversing the order of the first name, last name, right? Or your surname going first. That messes machine learning up, especially when you're talking about cultures where the naming convention is a little bit different, like, you know, in Chinese and Japanese, for instance, where the first name and the last name, right, is not always like the same as every other country. So you have to be very aware of that. That there's different meaning to the order of things. So another example of this is in scholarly data. Depending on your domain, your discipline that you're writing in, if you're the first author, that might mean you are the primary author. In history, for instance, that's true. Or in medical, if you're the last author, you are the primary author, right? That's not written anywhere. So you need to like be aware of some of these things when you're going in. And controlled vocabulary versus a keyword vocabulary is also very different. So again, if you're using scholarly things, you know, you'll see often there's like the author keywords versus, you know, the controlled vocabulary tags. Going back to, well, sometimes authors will put, and I saw this all the time, they would put tags on their document or on their research that they wanted their research to be about because they wanted to have more impact. They wanted people to cite it more, but it actually wasn't about that thing, right? It was more wishful thinking. So you have to be aware of those things when you're getting into the machine learning space because it's going to be a lot of false positives. It's going to be training your machine on incorrect context because if you have those tags on an article and then you train the machine learning on those documents because it had those tags, now the machine is learning the wrong things, right? So if you have a tag on your content that says it's about you know, COVID vaccines, and then the actual article is not, it's really about the syringes being used or something. Those are not the same thing. So if you have enough of that training happening, your machine is going to go off the rails and your F score, which is the happy medium between precision and recall, is going to go down and you don't want that. So you have to be careful about that. All right, so common issues to watch out for and why do they exist at all? So outdated terminology, we already touched on this a little bit where, you know, things are just a little outdated because folks are not updating it as regularly as you would hope. There is fuzzy broader term and narrow term relations. So if you look across a vocabulary, sometimes you'll see here with the electric vehicle example, the circular reasoning kind of happens sometimes with taxonomies. So when you're, you know, mapping that in, it will change the context, unfortunately, it will sometimes get into the machine learning if you are then training on those taxonomies, or the content that it's tagging. And that content can be open, right? Like the Transportation Research Thesaurus is the tagging structure for the Open Transportation Research Board, which is a US government institution for a lot of regulations for transportation. Well, you can see here they have scope note and definition is the same thing. This happens all the time. I mean, when I ask people, what's the difference between a scope note and a definition? A lot of people don't know the difference. Scope notes are supposed to be for guidance on how to use that in tagging. And typically that was used for when people were doing manual tagging, but now these are really helpful when you're trying to train or write rules for machine learning, right? Because now you know explicitly how this tag should be used in tagging. The problem is a lot of people mistake this for a definition. It is not the same thing. Saying how you should use, let's say a test, let's say an article or an asset you have is about a certain type of test, like an A/B test. Defining how those tags should be assigned is different than telling me what an A/B test is, right? So that's the difference between the two. And that's where you get into the poor definitions and scope notes. Bad forms, like I said, with the reverse order in entities, you would think that that's not a terrible issue. And if you know about it, you can easily go through and do a transformation to swap them. But it's a lot of extra effort, so just be aware of it. Also, any special characters for names too is another one to be mindful of. Over indexing. Oh my goodness, this is the second bane of my existence. Where you can see this tagging structure at the bottom. More tags does not mean better. The typical rule of thumb is you want to have between 3 to 7 tags. And you all might be asking yourself or wondering, ooh, I have more than that. And that's okay, but go in and really look at them and make sure that they're not being over-indexed. So over-indexed means you're trying to basically replicate the role of your search index, because the search index is looking at all the different keywords and words that are in the either metadata or the full text. You want to make sure you're not replicating that in the tagging structure. This is so prevalent because search engines haven't existed all the time, right? And so we were doing a lot of this because we didn't have search engines or didn't have very good search engines. Now we do, so you don't need to do that. You really want to make sure those tags are optimized for search engine optimization, right? The search engine does the keyword stuff. You don't have to worry about that. But the word that you use, that you see in the text, is that how your users would be finding it? Is that how your organization would describe that thing? Really thinking about the use case for discoverability is what you want to think about with those tags. But when you're training machine learning on it, it's going to learn all that over indexing, and it's going to think that the text in the document represents all of the tags that are on it. So that's where that misalignment comes in, because you're now over indexing it, and you don't want that to happen. Circular logic, like I said, is where the tag ends up somewhere else in either a much deeper into the hierarchy, or especially if you're dealing with a poly hierarchy, it's showing up in weird, strange ways, and the machine learns the path of your taxonomy. So you want to be very aware of what it's learning. It's learning, with this example, that alternative fuel vehicles, a sub component to that is electric vehicle, which honestly, those two don't really go together anyways. And then you get the plug-in electric vehicle as a sub to electric vehicle. That makes sense because it's a type of, right, which is a child of electric vehicle. And then you see electric Tesla as an example of an instance of a plug-in electric vehicle. And then you get electric vehicle again to describe what Tesla is. But you see the circle, right? If you get too far into your taxonomy training, that's gonna show up. Then you have categories versus specific tags. This one, again, is very common, where you might have a term that is electric vehicle, which is very broad. and it would be the container of a lot of things. You would maybe consider this a class versus an instance if you're doing true ontology. You want to make sure that you are training on the instances of and understanding the label for it, which is the class, instead of just the broad categories, because those are not as helpful. And then you have unknown or unfriendly context and schema. So you'll see here some of the repercussions of what we're talking about here, where there was a lot of terminology pulled just straight from the text and not from tags to create this. Both of these examples with the swear word and the byline Donald Trump one, these are both from scholarly research databases. And it's because the tagging on the content was wrong and not sensitive to the end users, right? So scholarship, yes, includes scholars and research institutions, but the one with the byline one, and you can see some of the other, and I'm specifically not saying it here because I don't want it to get flagged by any algorithms. This one is also a database used in younger children. So these are things you probably wouldn't want showing up. So you have to be aware of the end use case for these things. Okay, so what to look for when you are going out to assess the context for your machine learning. You want to look for provenance, right? Where did it come from? Who made it? Do they still exist, right? You definitely want to look at UIDs or APIs. And it's both. So UIDs is going to help you do the mapping, right? So you can connect all those IDs instead of the labels. If you use the labels can change, right? And then you're going to have a lot of mapping and a lot of deduping and a lot of problems. So try to use UIDs as much as possible and try to use APIs as much as possible so you can automate some of this. Then you have the issue of pre versus post coordination. This is a very librarian-esque word for it, but basically what that means is when you're looking at a good example is medical terminologies often have this, where pre-coordination means that the tags can be squished together. So you have multiple tags and they are squished together by the indexer to create a new concept that is then tagged to the content. I get that that's been best practice, or I wouldn't say best practice, it's been common in the medical space specifically. It's really hard for machines to understand that though, because there's all of this knowledge that the indexer has as to why these things are being combined that the machine completely misses out on. So if you can capture why those things are being combined the way they are, then you're in a better space, but oftentimes that doesn't happen. Post coordination is what modern search engines do when it's looking at your tags. So it's looking at these two tags or these tags all combined to create a concept. So a good example is electric vehicles, noise cancellation, and pedestrian safety. Those are all 3 tags. But together, right, for your context, this is a real use case from my past, is electric vehicles don't have a lot of noise, and therefore there was a lot of pedestrian safety concerns, right? So it kind of creates a context. That is more modern versus the pre-coordination. You really want to make sure that there are more definitions and not as many scope notes. And you want to make sure that these have citations and links if possible. So knowing where that definition came from. I got into a bunch of trouble. The company I was working for back in the day got into a bunch of trouble where we had licensed a bunch of dictionaries and we were using them, and then we were putting them up, in the solutions that we were providing. And what we found out was the people we were licensing from, we thought they created those definitions. They didn't have any citations. And because we were licensing, we thought, well, that's, they made them. Nope, they took them from Encyclopedia Britannica and never cited it. And you have to pay for that. So there was a lot of problems that we thankfully didn't have to worry about because there was a third party, right? Like we had licensed it and it was their fault for not telling us. But Anyways, be careful about that. How sensitive and historical data is handled. Sensitive data, you really want, like I've mentioned a few times, can't stress enough. You have to be very aware of what you're ingesting, who it's going to apply to, who that data set is based off of, was it ethically sourced, all of that stuff. You really need to be, and that should go into the provenance piece too. Being able to have someone you can reach out to and verify. There's a lot of AI ethics that are out there now where you can go through and look into what is considered ethical, how you can get those checks and that sort of thing. Again, have a lot of videos on that too because I feel very strongly about that. And then how historical data is handled. So another example from my past, you can tell I used to work for manufacturing. Is from electric vehicles. I had tags on magazine articles from the 1940s talking about electric vehicles. And I was like, wow, that's cool. They had electric vehicles. I went back and I looked at the context from the 1940s was when it had an automatic starter to the vehicle, they considered it an electric vehicle because it would start without having to crank, right? Totally different context from what we would imagine today. So you have to look through how our previous definitions, like we're talking about, illegal aliens, you will still find content from previous that might say those things. And you need to be able to, capture like this is no longer used. When was it discontinued? What do you do if you find it? Making sure that those things are handled appropriately. Then you also want to look at the source, how many ingoing and outgoing links it has. So you can look at this if you go onto linked open vocabulary and you can look up different schema. So like Dublin Core, you can see has a ton of ingoing and outgoing pointers because it's being used across a lot of different industries in a lot of different schema. Something that has less things going in and out might indicate it's not being used as such, or maybe it's very, very specific to maybe the art community or the economic community or whoever is using it. But it's a good indication of how many folks are using it. And that helps you understand if it's interoperable, is how if you map in the schema, not just the vocabulary, but the schema itself, how much can you get a bang for your buck? Because, other people are using it, like Dublin Core is a good example. It's being used in a lot of different schema that you can map in. Who maintains it and what is the data governance around it? Even if the source is authoritative and, the context, is a certain quality, like a good example is there's a lot of linked data sources now that are starting to report their quality of the data because they're looking at what's called triangulation, which is, trying to verify the data in other resources. That's really good. But if you're looking at the data governance and you notice that it didn't get updated for a year, is that okay for your use case? Do you need stuff that's more current? Do you need stuff that is getting a regular quality check on it? You need to make sure that you're aware of those things. So the root source, social media, scholarly articles, DataGov, all of those things are where did the data come from and what is the composition of that data. You want to make sure that you understand that for your machine learning applications because social media and blogs and things that are more laid back and not as scholarly tend to have different terminology that people are using, right? Like the words that I'm using right now with you are very different than if I was talking to my mom, on Sunday, morning or something. The words that you use in different contexts are going to change. So you need to make sure that you understand where the root of the data came from, not just the source of the data, but if it's social media, it's going to have a different level to it. There was a lot of examples in the past of people using, Twitter data to train machine learning, and it went off the rails really fast. It got really detrimental based on a lot of like hateful comments and things. So you just have to be aware, like some of this data coming in might not flag initially, but in mass, it actually might be problematic. So you have to be careful about that. You have to look at, is it a general specification versus a specific domain? So if you are looking at the, let's say the engineering space, if I went to the Library of Congress, it is woefully inadequate. Like, it's a good starting point, right? So I can get some data from that. And again, there's national libraries across the globe. So name your favorite. That isn't going to do the trick if you have your organization is focused on manufacturing or materials manufacturing even. So a good example of this is InSpec is a good vocabulary for engineering in general. It doesn't maybe go to the depth that you need for materials engineering. Maybe that's what you need. That's where you have to decide based on what your use case is. How much can you reuse from the open web and what you need to gather on your own. Or another example is the difference between, I did a study on this actually during my PhD studies, where I looked at the most common vocabularies for engineering, and I used the Library of Congress, NASA, the National, the one I had here, the National Transportation Thesaurus, and InSpec. And what's interesting about that is the vocabularies across the board when you're mapping them together. And this will include your own when you're mapping them in too. You would think they are all created by subject matter experts. So they should have a pretty high degree of overlap or agreement. Nope, nope, nope. In fact, they only agreed 23% of the time. That's it. And that's pretty high. Like, I would honestly, like, looking through it, some like the Library of Congress was way less. But they defined things differently. The hierarchies were different. They didn't even have the same terminology for the same things. So you just have to be very aware of these things. Usually you want to do an audit of the sources before you get into the mapping process, because they can be woefully inadequate or very, very different. And then lastly, like the schema and the framework that they're based off of. If you're using linked open data, it's probably using linked open data standards, like Dublin Core or FOAF or SCOS or, some of those things. But if you don't use them, that doesn't mean you can't map them in. It just means it's going to be a lot more effort, because you're going to have to try to figure out, well, what is this thing compared to that thing? All right, so where does this stuff really belong in an architecture? So the machine learning and knowledge models, you can either do them before product or after product. So before product is really where you're extracting data from the tags. You can use this to create your taxonomies or create your knowledge graphs. You can extract from the structured to create the taxonomies. That's usually the easier way to do it. If you're mining from unstructured, it's a lot more complicated, but it still can be done, especially if you're starting from scratch. And when you're doing the machine learning training, you can also look at the existing tags to create your training sets for your machine learning. So what does that mean? So let's say you are trying to train your model to do auto indexing or auto classification. If you have been using human indexers for a very long time, and by the way, the big human in the loop part in the middle is still there. One of the biggest misconceptions when you're talking to your stakeholders, if you're like, hey, let's go with this machine learning, it's going to save us lots of money and time. No, it's not. It's not going to be easier. It's not going to save you a lot of money. It takes a lot of money to run these things. It takes people still to train them and maintain them. Will you find more efficiency? Yes. Will you be more consistent? Yes. But be aware, when you're getting into machine learning, it does not mean you get to clear the board of the people who were doing it before. So I'm giving that advice because I've been there way too many times where I've had to be the one to tell them the honest truth about what they were trying to achieve. But when you are going in and trying to train your machine learning, you can use the tagging that was done by humans before. Again, it's not going to be the most consistent because humans differ. There's a great article talking about inter-indexer agreement, and the agreement is not very high. So what that means is if you have many different indexers, human indexers, they're going to be tagging things differently than if you have a machine doing it. The way it usually runs out is that humans are about 90% accurate, right? But very inconsistent. And so you get a very high accuracy, but the inconsistency makes the search and retrieval very hard, because now the machine has to figure out all the different tags that somebody used to represent that concept that someone's searching for. On the other side of the coin, which is after product, you can extract the data from structured for ML enhancement. So what does that mean? It means that once the tagging is done, right, you can actually use your machine learning to, again, finding those documents that have the same tags, and then start to mine words from that full text that could be used to enhance the terms that you have in your taxonomy, and also that are in the knowledge graph to do search engine optimization. So what does that mean? So if you have all the documents that are tagged with cat, and you notice that when you run it through the machine learning, it starts to pick up on common phrases or common aliases for cat. You can then take those word clusters basically and map them in as alias to cat, so that when your machine learning is running, it's kind of doing all of that hard work for you. And then when you're doing your search optimization, the knowledge graph is behind the scenes and it says, oh, I see cat is what somebody searched on. Let me use my BART right now. I'm going to get into some of the applications you can use to do this, or techniques that you can use to do this. And let me see what those words map to in the context of my organization, because you've already added that, right? So, with your ethnographic studies, what do people call this thing, or how do people use this in your organization, plus the actual words in your full text. Okay, so what to do if your own data is missing context, and how do you add it back in? So here's a bunch of different ways that you can use that, or use these mechanisms to do it. Some tips here. So node attributes is the characteristics of similarity. Is why are these two things related to each other? That context in a knowledge graph application, you can get this from conditional random field algorithm, top to vec. There's a lot of 2vecs in here because those are very vector space is really helpful. If you have a vector database, you are way ahead of the game on this stuff. Not suggesting you have to have one, but it does help with some of these things. And then, NLTK is another approach to this. Structural features, so the connections and types of connections. So that's if you're looking at the triple, it would be the relationship between the two nodes. So looking at hierarchical algorithmic clustering, lots of clustering actually helps you with this to kind of understand like what relationships things have with each other. And then doc to vec is a good way of understanding this, is when the document space, what do these documents have in common? So it's another type of clustering that's very helpful when trying to understand the connections between nodes. And then node embeddings. So the surrounding clusters and nodes. So how are all the nodes connected together once you have the similarities to things, as well as the types of connections between things? So you can use deep walk, node to vec, and BERT, and probably a bunch of other ones now. A lot of LLM stuff goes into this space too. I've tried to leave those things out because that stuff changes so much every day now. So I'm just trying to like note it without putting it into a slide, because by the time I put it in a slide, it's already outdated. Okay. Okay, so retain and recovering your context. There are some resources here that I wanted to make sure that are here. I'm not going to go through all of them, but I am going to go through in how you add and retain. So adding context. Using existing linked open data sources is a rich area for data sources and for additional context. But again, keep all of the things that we said in mind when you're reusing them. When you're looking at types and categories, that's something that I think is really helpful when adding more context. Is what do these things have in common? And that will give you a roll-up value of what your information is representing. So if you have a long list of companies or people, what do they have in common? And then understanding those commonalities will give you a representation of the context that they share, the attributes, right? If you're using properties and things, what they share, that is a way of helping build out the knowledge graph. Confidence scores and data governance. So understanding the confidence that two things are related to each other when you're talking about an instance level, when you're mapping the taxonomies together, how confident are we these two things are the same thing because they have metadata, hopefully. If they have no metadata, you have very low confidence because you have no idea. If this Selena Gomez and that Selena Gomez are the same thing, you have no idea because it's just a name. If you have that issue, you can maybe look at the content or the assets that tag is represented on, and maybe you can gather some more data that way. But having a confidence score on how similar they are, and then on the knowledge graph level, it's how confident are you that Selena Gomez and Taylor Swift are related? How confident are we on that? That is very helpful because your machine learning, right? So there's a few things you can use this for. So in machine learning, that helps you understand how confident the machine is that it got it right? So if you give it training and it tells you, well, this is what I learned from my training, you can then assess whether it's like a test. Did you get it right or did you not get it right? And that's the confidence that you can get. And that helps you determine if the tagging that you did, so again, this is like pre-product, is accurate, or if you're going to automatically accept it, or if you need a human indexer or someone like a subject matter expert to look at it. On the other side of the coin, post-product, how confident are you when you're on the knowledge graph side that these two things are related to each other? And there's a confidence score that you can add to that. And that helps you with your analytics or your recommendations or whatever you're using your knowledge graph for to understand, your threshold, your benchmarks. Do I want to accept something or not based on that confidence score and the data governance around it? Because when was that confidence score calculated? What data was used to calculate it? That stuff is so missing in my mind from a lot of data governance pieces in the machine learning space. When was it calculated? What was it calculated on? The world is changing constantly. So you want to make sure that there's a refresh of content and that is regularly tested so that the confidence is still accurate or not. Machine learning results are only as good as the search end user deems it. So A/B testing, please, 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 A/B testing, whether it's real A/B testing where, there's lots of tools out there that allow you to do like real A/B testing where there's like, stuff being inserted for certain users, but not others. You can do this with tools like, what's it called? TreeJack, things like that, where you can like make sure that things are in the right places and kind of test it that way. You can do card sorts, that's the old school way of doing it, but you can do them digitally or in person. Again, I have a whole video on some of these things, but just because your machine says it's confident it got the right score, just because your indexers say, yep, this is the right tag, this is the right way that we're going to add this is the right search results that should come back, wrong. You don't matter. I'm sorry. I know that's painful. Painful. Your users matter. Your use case matters, right? Your stakeholders matter. Test with them. Make sure it works for them. That's something I know a lot of folks. It's going back, again, that librarian-esque like user warrant versus literary warrant, versus scientific warrant. If you're not familiar with these three things, look them up and look into them. But like the long and short of it is scientific warrant is what does the documentation and the scientific like research community agree is the right way to present it. There's literary warrant, which is, and scientific warrant could usually be like the taxonomist or the information professional, right? Like there's a professionalism, like, ivory tower sort of thing. Then there's the literary warrant, which is what does the documentation actually say about it and the words that are used, versus user warrant, which is what your users actually use. You want to have all three. They have to come together to make this really effective. And then retaining. So register UIDs if possible, or at least document their logic of how your UID is generated. This is a weird one, but people, I feel like, just make UIDs up and they don't document how they are made. And you know, the registry is helpful because when you're mapping different vocabularies together, you need to know if they're actually UIDs or not, because a UID in your database might not be unique after you add a new database in that might use the same one. Provenance, again, is a good way of retaining your context, because you know where it came from, you know who touched it, you know when it changed, you know when it was sunset, you know, all of that good stuff. Test every few months to make sure the data is still good. That's a big one. And train your indexers, your digital asset managers, your KMs, and your ML engineers. So it's not just training the machine learning, it's training everyone else that's using the tools as well as the outputs, right? So making sure everyone's on the same page as to what it is, what you should do with it, you know, where it came from, all that stuff. All right, last, because I know we're coming up on time here, I think, is different mapping models. So crosswalks are very common. If you look at schema mappings or vocabulary mappings, it's usually a one-to-one. Here's the problem with that. Once you get past 4 vocabularies or 4 schema, it gets to be incredibly difficult to maintain and very costly to maintain, which is why you go to the hub model, which is a knowledge graph model, where if you have an ontology, that's the red circle here. Or if you have your own schema, it's the red circle here. It's mapping everything to one canonical schema or mapping everything to one vocabulary is way easier to maintain and less costly, because it means the data can continue, like the source data coming in, can continue to morph and update, but the mapping doesn't have to be updated unless, and this is where you have to make sure that you're testing it constantly, is to make sure that the context coming in doesn't change. So back to that electric vehicle example, if I originally mapped in electric vehicle to mean an electric starter, because I made my mapping, 20 years ago, electric vehicles, modern ones, come about, that term now changes and its mapping needs to change. So that's why you have to constantly be monitoring to make sure that it's still sound. But that's where the hierarchy will help you, because the hierarchy probably will change. The definitions will likely change, right? Having a change log going into that data governance is going to be very helpful for you to know when something is new or updated or sunset. And when you use a knowledge graph, right? So again, you have your class and it means cat and all the different tags. And even if they say cat, they're all different UIDs, right? And you need to map them all to your canonical, which is your knowledge graph node. And that will help you with a lot of your data integrations. It will help you with the translations between different systems. If you are using this with vocabularies, it will help you add these as synonyms to do embeddings in your search engine, right? So that means if your search engine sees this red node, which means cat, it knows all the other tags on your content or the context for cat. And that's a huge benefit to your search. So making sure that those are captured. And when you're doing this mapping, you have to decide if you're going to match exact matches or partial matches. So if you're doing a lot of mapping, a partial match would be like if you have something that is a real example, precision and recall as one tag. Would you map that to precision as a tag and recall as a tag if you have them as separate, because they are separate things? Do you map it to both? It's a partial match, right? You have to make that decision on your use case, but you need to test it and you need to make sure that it's going to meet the requirements and the understanding that your users have. And then when there's no match, what do you do with those? Do you leave the data on the table? Do you make a new node in your vocabulary and then, hope that more tags come along that you can map to it? Again, I would caution preemptively doing things. Maybe keep those. This is what I've done. Anything that doesn't map in, you go back maybe quarterly or yearly and just go through the other vocabularies that you have to see if more, or even schema, right? Even more of those are showing up, and then maybe that's your trigger to add it to your knowledge graph or your mappings. Don't do it until you have evidence to do so, because you have to pay for it. You have to maintain it. It's going to cost you something, and so make sure you know that you are willing to pay that cost and the benefit of it. All right, so that is it for me. I know I went kind of fast. There's a lot of topics here that I tried to
Yeah.
cover that kind of all are on that same vein of contextuality in machine learning, knowledge graphs, and taxonomies. But with that, I'm going to open it up to questions, and I'll actually close out my screen so you all can
Thank you, Ashleigh. Thank you very much. Yeah, so maybe just to open it up to the floor, is there anyone that has any questions or comments? I loved some of your terminology, especially around the canonical models. We use that extensively in integration. So let me see. Is anyone, Mark? I know you've been working with the knowledge graphs and graph on Q6. Any comments from your side?
Yeah, no, it's refreshing to see someone young, not picking on you, but hanging around with John O'Gorman and Howard. We all have gray hair, so it's nice to see there's another generation that's on the track. That there's a lot of little tips in your presentation, Ashleigh. I enjoyed. I will be looking for your YouTube channel as well. It is something we struggle with. Classifying data and provenance are very, you said magic words to me when you said provenance, because a lot of people just don't think of it. So having practitioners like yourself out there spreading the news, the message, gives me hope. So thank you.
Thanks. Mark, there's this a question by Matteo, and his question, I think it's he said, "What could you say about fully automated knowledge graph construction?" It seems like that's not true after your people in the loop.
Yeah, so clay on the table, right? I think that as much automation as you can do, the better, with the understanding that it's not going to be perfect, and you do need people to go in, validate it, make sure it's the right, construction that you're looking for. It's going to meet your own use case. It's not a set it and forget it moment, right? And so that's where the human in the loop comes in. Like, do you need an army of people doing this? No, but that's where automation is the best. Is if I had to start from scratch, it's going to take me a lot longer, and I am a human, so I can only look at so many things before I have information overload. But if I'm automating it, the machine can look at everything. It can take everything into consideration, and it puts it out into the prompt that I have asked for. But I still need to check that it makes sure it makes sense for my use case. It makes sense for my what I'm going to be using it for, not just my use case, but like if I have like certain system requirements and that sort of thing. And I have to make sure it makes sense for my user. And I guarantee there are going to be things that you need to update. So yeah, you can automate it, but it's not going to be fully automated. Like there's always something that you have to go back and tweak and make sure that it's actually going to do what you think it's going to do.
And then of course your comment about data governance in terms of when last was this the frequency of updates and all of those issues. You need to bring in that constant review.
Yeah, and that's the thing. Like if you are generating a knowledge graph, yeah, I mean, the other thing is I think a lot of people think that creating a knowledge graph is this like mega project, and it used to be. But it depends on what you're using it for, right? Like if you're just using your knowledge graph for analytics, you can use, and again, not to keep plugging my channel, but I do this on my channel so people have like things to refer to. There's a lot of tools now that you can spin up a knowledge graph based on a use case and the data that you have, do the analytics, get the analytics that you need, and then flush it. you don't have to continue to maintain it, which is great. It makes it way cheaper if
Yeah.
that's what you have, right? It's not everyone's use case though. But that's, something to consider. You don't necessarily have to build out this giant architecture and this giant new thing if you don't actually need it.
Fantastic. Matthew, I don't know if that answered your question. Are you comfortable?
Cool.
Okay, fantastic. Anyone else? I know, Don, I know you've been thinking about it, but as I said that, I think he dropped off. Sorry about that.
Yeah, I think I went over. I didn't mean to.
Not
I
a
was worried I
problem.
wasn't going to fill the time, and then I
Yeah, no. So Ashleigh, something we've been doing now for quite some time is we've got all these webinars and we have all these discussions around data management, and of course our base, almost the hub that you refer to, is the DMBOK, which is our data management body of knowledge.
Mhm.
And I love what you talk about there in terms of constantly mapping back to that. But we also know that the DMBOK has certain levels of inaccuracies as well, and things change on an ongoing basis. So what we're trying to do is, as we have people like yourself talking, one would say, well, okay, this is a new set of tags that have been developed, and like your use of the canonical model, and how would we map that back to the body of knowledge, or the DMBOK?
Mhm.
So that's certainly something that we want to be doing. Is we've got in the region of 300 videos, and people talk about different things, but we'd always want to bring them back to the body of knowledge, which will help people when they study for certain certifications or exams, that they're constantly mapping to that same hub.
And yeah, that's where I think knowledge graphs are really helpful, is when you have a lot of different dispersed, systems and people and things. There's the National Science Foundation is now looking into, I think, an open knowledge graph, either framework or a graph itself. I can't remember, but it's something to watch for, because I think whatever they are going to be developing could be retrofitted for a lot of other use cases, which is fabulous, because it's kind of like the personal knowledge graph situation, but it's all of you as persons creating a knowledge graph together. And
Right.
the biggest pushback I have on the personal knowledge graph space for this is there's no easy way to collaborate on
Right.
developing a graph like this, especially for the folks that have different levels of understanding for graphs. So, that's something I keep asking the PKG standards groups to figure out.
Okay. Yeah. And the one thing that I wanted to ask you was, you spoke of that number of tags from, I think you mentioned up to 7 tags, or something like that.
Mhm.
I'm trying to, and that's used for people searching. Now, I'm not sure I fully understood those 7 tags. Is it it can't be for everything in your domain? Is it around a concept that you have that limit?
So
So
the
if you
tag
wouldn't,
content. So your taxonomy or your knowledge graph can be as large as you need it to be.
right.
But when you're tagging content or assets with,
Okay,
that's where you have the 3 to 7. And so the reason it's 3 to 7 is because that's the typical amount of like keywords and concepts that people have in a traditional search. That's why
right,
yeah,
right,
that's the
right.
tag.
Okay, so for example, we've got the DMBOK has 11 knowledge areas, and they've got loads of different essential concepts. So that's a massive graph. But then, as we bring a webinar in, you wouldn't want to tag it with more than 7 elements.
Yeah, because I'm assuming that you're tagging it to be able to retrieve it at some point, or gather it
Yes,
to like-minded things. Yeah, once you get
yes,
7, you start to get into that over-indexing space.
Right.
Yeah, or you add tags that don't need to be there. Like I've seen people add tags that should be metadata tags instead of, taxonomy. The taxonomy is the aboutness. What is this thing about the
Yes.
top context? But I've seen people start to use like, well, this was done in 1980 whatever, resolution or something for the video, and it's like that should just be in the metadata. That shouldn't be a tag. That's weird.
Right. Okay. Fantastic.
No offense to anyone that's doing that.
It's amazing what you're saying, because I went to a talk in EDW when I first heard of ontologies in 2017. They were talking about fiber, and the one lady the thing that struck me was just saying, her comments was just how bad some of the taxonomies ontologies were, because they weren't constructed properly, and I never really understood some of the challenges that you've just raised now in terms of bringing this stuff together.
Yeah. Fibo is a weird animal. I have a video all about that.
Okay.
Yeah, and it's interesting because I don't think we do a good enough job at educating folks. I mean, that's
Yeah.
again, I do the channel is Fibo shouldn't be used by itself. Like it shouldn't be used as a vocabulary or an ontology. It's there to pick and mix and match and take things from industry experts. I've heard so many people that are getting into this stuff to say like, how does anybody use this? This thing is massive. And I'm like,
Yeah.
it's not meant to be used all as one unit, right?
Right. Right.
But it's and I even remember talking to a CTO at one point about linked open data and how you can mix and match the schema, right? You can have your schema that you've created with Dublin Core and Fibo and Obo tags. Like you can have that as your schema, like you're mixing and matching things. And he just had no idea. He's like, wait, why wouldn't you just pick one schema? This is weird. This is going to be complicated. It's like, well, it's not. It's actually like on purpose.
Right. And you're connecting them back. Oh, fantastic. And the thing I loved about what you brought in is something I've been looking at is we refer to them as data principles, and there's the fair that you mentioned a lot in terms of research, that it's findable, accessible, integrated, and reusable. And then I noticed that people were bringing in care, which was the people side of it. So that's the indigenous people, and someone did a really nice mapping between care, fair, and open, in terms of how slightly different they are and different purposes that they have.
Yeah, and that's the thing. Like there's so many amazing little nuggets of data out there. People that are so passionate and getting stuff out, but they don't have the knowledge or the resources to get it out there to more folks. And that's what I so desperately want to help with is, there's such good stuff out there and it's just so hard to discover it, so hard to find it.
Right. Yeah.
And so they're doing this great work, but nobody really knows about it. Which I would that's why like getting linked open data cloud out there, you can register your data there, right?
Okay.
Like if you are building something really amazing, do that. Make a Git repo of that data,
yes.
right? Like that is fabulous. People are constantly looking at GitHub. Go in if you don't know how to make a data set, right? Like a lot of people I was talking to on the indigenous side, they talking about a data set, they don't know. The lay folks that I was talking to, they weren't in tech, of course, didn't know what that really meant. And I said, well, you can all sit down and just like come up with the words that you use for things, and it can just be an Excel file, and you can just upload that. But even something as straightforward as that to a tech person, it for some folks, they don't use Excel. Like they're like, what's a cell? Sometimes maybe that sounds a little off-putting, because like, well, of course people are going to know that. Like, it's not. If you don't use it in your day-to-day life, it's not something that you're familiar with. And so trying to make this accessible, I think is drastically needed.
Excellent. Fantastic. In any, I know we've actually just got Naresh and Mark and Debbie hanging around with any final comments or questions from you, Mark, or Naresh?
I'll just comment. It didn't occur to me, Ashleigh, to mix and match schemas in a single model either. Like I just didn't. I was one of that. I pick one and then the search to find the right one that best describe my situation for my current project, right? To set that context boundary. So yeah, now I gotta think about that. Now you've caused me to think. So good on you.
Sorry.
That hub model is fantastic. I hadn't thought about that either. But really nice.
Yeah, I mean, think about it. Like if you go in and look at, trying to think of some good examples. Music Brains is a good example. Like if you go in and you look, they have so many things mapped, but their ontology has FOF in it. It has Dublin Core in it. It has like a few different ones, right? So it's out there. People are doing this. It's, it is a little more complicated than just picking up Dublin Core and just using that. But I think when you do that, you run into the problem, then you're going to have to extend it a lot because it's not meeting exactly what you need. But like, go look at some of the other ones there. Like linked open vocabulary is a great place to look for that because all of the linked open schema are listed there. So go in, just do a search, right? Like I do this all the time, trying to add like, I think it was composer or something. I was trying to find if there's, a schema that already represents composers. And so I just went into linked open vocabulary, typed it in, and I found other schema. Again, I checked them. Not all of them were reputable. Not all of them were used. So I started those. But it's a good starting point.
Yeah, search on linked up open vocabularies returns. Yeah, good. There's a lot of vectors there. Thank you. Good stuff.
Fantastic. Ashleigh, thank you so much. We really appreciate you sharing your knowledge and understanding. Thank you.
Thank you so much, Ashleigh. It was great learning from you.
Thanks. Bye, everybody.
Hope you sleep well. Bye.
Bye.
Bye-bye.
Cheers, everybody. Cheers.
See you, everyone. Bye now.
Cheers. Cheers.